Alright guys, this is your video on basic perspective. We're calling it basic because I'm not going to get into a whole lot of detail in the video. Instead what I'm going to do is give you some vocabulary words and some laws that we can work with when we see each other in class next. And then I'll answer all of your questions there. You've got vocabulary words, so you need your logbook and a pencil, and I've also got some drawings to show you. You can, we'll talk about that later. Alright, so your first word is illusion. An illusion is something that tricks the eye into seeing something that isn't actually there. Perspective is a way of creating the illusion of space or form. So, for example, this probably looks like you could walk into the drawing, but in reality, it's a flat piece of paper. So, it's an illusion. Your next word is 2D. 2D is short for 2 dimensions. It means that something is flat. It has only height and width, like a shape. If I were to draw a shape on a piece of paper and the line closes, we've got a shape. It's only got height and width. This piece of paper that this is drawn on is 2-dimensional and flat. You can see it when I put my hand on it. 3D is a form. A form possesses height, width, and length. Sometimes we call length depth. A form exists in 3 dimensions, and examples are my cup. You can usually wrap your hand around forms, right? Another good example of a form is anything on my desk, as well as our friend Devin.
Hi.
I keep calling him Dylan. Devin is a form. We have illusions of forms here. And I've also got an illusion, 2 illusions of space. Space is really just a form turned inside out. So these are forms, right? And if we were able to walk inside of them, we would now be in a space. 3D. Vanishing point. This is when things get really exciting. Vanishing point is where converging lines meet and where objects appear to disappear. So, where objects appear to disappear, let's tackle that one first. If you were to stand, you can try it, stand by the side of the road and then watch a car as it drives away from you, especially if you're in a location where it's flat, eventually that car will look like it disappears. Where it disappears is called the vanishing point. I'm going to come back to this one. Converging line. Converging line is a type of line, a type of diagonal line that travels directly towards the vanishing point. Okay? So, the vanishing point is where converging lines meet, and a converging line is a type of diagonal line that travels towards the vanishing point. So in this drawing, every diagonal line is traveling towards the vanishing point, and it looks like they meet there. They are converging lines. In this illusion of form drawing, all of the lines that move backwards and away from us into space are converging lines. They go towards the vanishing point. In this illusion of space, I have kept the extra lines that I would normally erase there, so you can see how they continue towards the vanishing point. This is what trips most of you guys up. You have 2 ways of thinking. You have a logical way of thinking and a spatial way of thinking. The logical way of thinking focuses on what you know. For example, you know that these lines in the wall are straight and they never ever touch. But when we look at it spatially, it seems as though they get closer to each other the further away they get, and they eventually disappear or converge at the vanishing point. It's the same for these forms. Logically, you know that these lines are parallel or straight, but when you look at it spatially, they look diagonal and like they travel towards a common point, the vanishing point. The biggest thing that we have to get over is trusting what we know. You need to forget what you know about forms and spaces and focus on what you see. Copy it down exactly in order to get an accurate illusion of three-dimensional space on a two-dimensional surface. All right, next we've got parallel. Parallel lines are two or more lines that will never, ever cross each other, even if they were to continue on forever. So again, logically, we know that these lines that travel away from us in the floor are parallel, and they would never touch if they continued on forever. But they don't look like that on a flat surface or even in a three-dimensional space. I'll show you a trick called sighting to prove it to you in class. The lines that are parallel are vertical and horizontal lines. A vertical line is a type of line that moves up and down, and a horizontal line is a type of line that moves from the left to the right. In these drawings, the vertical lines are all parallel to the edge of the paper, and the horizontal lines are all parallel to the tops and bottoms of the paper. So when I used my straight edge to draw them, I oriented it in a way that there was equal distance between my straight edge and the edge of my paper the whole way down. And I did the same thing when I drew my horizontal lines. Okay? Now, diagonal lines are a type of line that move both up and down and left to right at the same time. So if we follow this line this way, I'm going both to the right and down, and if we follow it this way, I'm going to the left and up at the same time. What you need to know is not all diagonal lines are necessarily converging lines. You've got to pay attention to them. But if they're moving away from you and towards the vanishing point, they are. This is a big reason why we're drawing the hallway, because there are no diagonal lines that are not converging in the hallway. Okay? So the biggest trick to using linear perspective to create space is being able to tell the difference between the lines that are horizontal and parallel to the edge of the paper, the ones that are vertical and parallel to the edge of your paper, and the ones that are, where's my finger? There it is. The ones that are diagonal and converging, even though we know that in real life, they are actually parallel. Check that out. So, again, horizontal, vertical, parallel, converging. And if we look at these tables, we've got horizontal, vertical, converging. Okay? Take a look at these guys again. If you would like to try to draw them, all you need is a box whose top and bottom is parallel to the edges of the paper, whose sides are parallel to the right and left part of the paper, and then you draw your converging lines from the corner to the vanishing point. Now you might be saying, but Ms. Gorski, how do I know where the vanishing point goes? And for our very basic linear perspective knowledge, it goes wherever you want it to go. All you need to know is, depending on where your vanishing point is, it will determine how much of the top, side, or bottom of the boxes that you see. Okay? So because my vanishing point here is not in the middle of my paper, it looks as though we're sitting off to the side in the hallway. All right, have fun. We got this done in like 10 minutes, and I will see you next time where we will take our own visual notes. Ciao.